Welcome to the Teachers College webinar series on teaching and leading in times of uncertainty. Today we are very lucky to be hearing about the topic of mathematics formative assessment, especially with respect to the current pandemic and what we can expect in its wake. We will first hear from Professor Irina Lyublinskaya, Professor of Mathematics and Education at Teachers College, and then from Christina Heffernan, Executive Director and co-founder of the ASSISTments Foundation, who run a free public math education service operated jointly with the ASSISTments Foundation and Worcester Polytechnic Institute. It is wonderful to see so many people interested in online math instruction and formative assessment, and I would encourage you all to ask questions in the Q&A tab, and our speakers will endeavour to answer as many questions as possible during today's session. The chat feature is also enabled, so feel free to discuss the session, share resources and reflections there amongst each other, but please be respectful in your interactions. Again, should you have a question, please use the Q&A tab. Finally, we plan on sending out a follow-up email with a link to the recording of this webinar. With that out of the way, it is a great pleasure to hand over to Professor Lyublinskaya to introduce the topic of mathematics formative assessment.
Hello, everyone, and thank you for being here today. So we are going to talk about mathematics formative assessment, as Charles said. So as we know, educational technology became a significant part of mathematics education in the 80s, when with introducing of graphing calculators, dynamic geometry software. Today, we have an abundance of various digital tools on and offline, but how to choose the right one for your classrooms, for you and your students. Fortunately, over the past 40+ years, mathematics education researchers were constantly studying effects of digital technology on teaching and learning mathematics. Before your fun time with Christina, I'll briefly talk about research findings and recommendations. So technology is the technology is changing the way we teach. And according to Celia Hoyles, technology really changes the types of problems we solve in mathematics. It provides opportunities for students to experiment with mathematics and immediately see consequences of their actions. And it also supports dynamic visual representations. So are we using technology effectively? Well, quoting Paul Goldenberg, it's not just the use of technology, but how it is used. And that defines whether technology has been used effectively for teaching mathematics. So what are our challenges, especially in evaluating technology use? I hope that many of you who are in the classroom right now can associate with this image. Most of us right now exactly in this situation. We have so many different tools. Coronavirus pandemic presented us with additional challenges when our teaching and learning moved online. And I'm sure most of you feel very anxious about. Many teachers already started new school year in New York. We're starting next week. Some of us don't know whether we're teaching online, in person, and hybrid. But the question is how to use technology effectively becomes even more critical now than ever before. That means teachers are expected to evaluate technology use while navigating through tons of offers for digital resources bombarding them. We need clear criteria for selecting tools and that are right for you and your students. And so Paul Goldenberg, in his article, Thinking and Talking About Technology in Math Classrooms, suggested several principles for the effective use of technology that are based on large amount of research. So these principles could guide teachers in selecting and implementing digital technology in their classrooms. I'm going to just summarize this. The idea of the effective use of technology is that it should help developing higher order thinking and not be just a motivational add-on tool. It should help students analyze mathematical processes, develop strategic thinking, and become independent of technology and problem solving. At the same time, Paul emphasizes the fact that students should become confident users of technology in order to be able to solving challenging problems. Now, how do we self-assess and how do we know whether to use a particular digital tool in the classroom? So researchers suggest teachers to ask themselves these questions. How essential is the use of technology in achieving the primary goals of the tasks for your students? How does the use of technology contribute to the goals of the task in a way that would be difficult to achieve without it? How does the use of technology support students' mathematical thinking? So the Sherman and Caton really identified those questions as a part of technology use. At the same time, Schultz talks about technology effects and identifies 3 different ways technology can affect our instructions. How use of technology enhances intellectual performance. He calls it effects of technology. So we're talking here about possibilities for technology to take some routine, busy work away from the students so that they can really focus on important mathematical concepts. The second question, how using technology may leave cognitive residues that enhance performance even without the technology or effects of technology. So in this case, we are asking ourselves, can use technology help students to retain the knowledge, the skills, and then being able to apply them in the situations when they don't have technology? This really well parallels of the principles that Goldenberg states. And then the question, how technology does not just enhance performance, but fundamentally reorganizes it, effect through technology. So in this case, we're really looking at the fact that with technology, we change the way we teach. We don't just teach the same way by adding technology for enhancement, for other tools, for like procedural skills, but we really want to think about how to reorganize the way we teach that technology allows us. So assessment is one of the most important strategies in the education process. It involves monitoring students, collecting evidence of student performance that could inform students themselves, their parents, and teachers. It serves the purpose of keeping all stakeholders informed about their progress towards teaching and learning goals. For students, it's how well they're learning. For teachers, how effective is our teaching? How effective is our curriculum? The number of web-based or app-based tools for assessment is astronomical. I don't even want to list, but many of us heard about a lot of different things. Kahoot, Socrative, Poll Everywhere, I can keep going forever, right? So back to question, how do I choose what's best for me and my students? How do I know whether these tools have been research-based and field-tested? And where do I find time to do all that? I can barely have time to learn new online teaching platforms and LMS that my schools just purchased for us to use. These are issues and challenges that we hear from the teachers all the time. And that is really the purpose of our webinar today, to introduce you such platform, ASSISTments, that is research-based and field-tested. So this is the references that I listed for those of you who are interested to read more about the research and applications in teacher education. But now I'm very excited to pass the ball to Christina, who will engage us in learning about ASSISTments, a research-based and field-tested platform for mathematics formative assessment that was co-founded by her and her husband. Please.
All right. Once you stop sharing.
Yep, I'm right there.
Okay, there we go. Awesome. Thank you, Irina. I really appreciate this and appreciate the opportunity to be here. And just a little bit about me. I'm Christina Heffernan, and I sort of honed my craft as a teacher after I joined the Peace Corps. I joined the Peace Corps to see if I liked teaching math. And I did. I did that for 2 years in Gabon, Africa. And then I moved to the United States and taught in Baltimore City. Then I taught in a private school in Pittsburgh. And then I taught at a school in Massachusetts. So I might not be the best way to hone my craft as a teacher by going to so many schools, but I definitely became super acquainted with lots of different environments for education. So when I then moved on to working on ASSISTments, which I started 15 years ago with my husband, I sort of have a very good sense of what schooling looks like. So thank you for having me. And Cindy Starks is also here. She will be answering some questions, looking at the chats as you guys put some things in. And and helping send some things out to you. So she's a colleague of mine and is here as well. All right, so let's get started. Here's today's agenda. So our goal today is to reflect on an online tool and how they support this formative assessment. And to begin, I want to just get us all with a common understanding what formative assessment is. I want to then show you ASSISTments, which is the tool that I spend all my days working on, and how it infuses with formative assessment, and then using that paradigm for you to look at all of your tools. Next, we'll look at the research, as Irina mentioned. Research on some of the tools we use out there in the classrooms is super important. And then at the end, we'll come back and have a discussion. I look forward to your questions. So this is my definition of the definitions of a formative assessment that I like to use. The one on the left is from James Popham, and its formative assessment is a planned process in which teachers or students use assessment-based evidence to adjust what they're doing. I really like this because it focuses on the process. It focuses on the fact that teachers and students are part of that. It also talks about the evidence, that you have to collect evidence and that you have to make those adjustments. So it's a short definition, but it really covers the big bases. On the right is a diagram, and who doesn't like a pretty colorful diagram, that is informed from Margaret Heritage's work. And this is sort of something that we will use today to look at ASSISTments and look at the formative assessment cycle and the process within ASSISTments. But what I'd like to do next is get a sense of who's here and what you bring to the table about formative assessment. So I'm going to shoot out a little poll here, and it should be out there. And the question is, on a scale of 1 to 5, how experienced are you with formative assessment? Awesome. So it's rolling out, but I'm going to end the poll and just let you see where we are as a group. Not all of you might have gotten a chance to submit, but that's fine. It gives us a sense of the room. And we're kind of in the middle. So I definitely have people out there who get it. They've seen formative assessment definitions. And then there's a few people who haven't heard about this at all. So let's make sure you guys get up to speed. And then I have some experts. So I look forward to your questions as well. So that's awesome. All right. So I'm not here really, though, to do a whole, we could do a whole course on formative assessment. What I'm here to do is to sort of touch upon what, how technology can help and support formative assessment. So my thesis is that in order to make it through a whole process, both humans and technologies need to have a role. The split of technology and humans in that role of the whole formative assessment process depends on what technology you're using. And I believe that we must ensure that the human touch is never lost in that process, but that technology can make the whole thing more efficient. So let's just break this down a little bit and look at each one of these parts. So the process sort of begins with selecting your learning targets. And in my world, the humans are really there for that part. So the humans have to decide, what are our learning targets? It's the teacher, it's sometimes the school district, the school. You sort of know what is it I'm trying to teach. So that's a human process in my world. Next is developing these criterions for success. And this also is the human. The human has to decide and make decisions about what's going to be success. How do we measure that? And a lot of times the teacher really should involve the students. It's sometimes a little difficult, but the students should also know, how do I know if I'm successful? Is it okay to make a couple mistakes? Or is it super important that I'm fast? Is it important that I do it seamlessly every time? And those things are something that the student needs to know, and the teacher needs to communicate that. The third thing is eliciting evidence. And I think this is really where that technology can really come on board and make these things more efficient. But it's important not to forget that the human involved in this process is that student. So we're going to elicit evidence of learning, and that we might use a technology to find that out, but the student is there, and the student is super important in that part of the process. Next is interpreting the evidence. So we need to look at it, we need to think about it. We can't just take our evidence and put it on the shelf. And the student should be doing some interpretation as well. And finally, we have this adapting. So how do we adapt? What do we do with that evidence? What kind of changes do we make? And feedback is everywhere in formative assessment. And but it really comes into play here. Like, you can't make adaptations unless you can't adapt until you have some feedback. And so the computer, the parent, the teacher, the students are all involved here. So that's the whole circle. I'm going to have Cindy put out in the chat a link to a PDF of this slide. That way you have access to it as we go forward, and you can always reference it. I actually have a printout right here for myself. And so if you're so inclined, take that, click on it, make a new tab, and so you can come back to this picture when you want to. All right, so that is the first part of our agenda. We've got a joint formative assessment definition. So we're all on this sort of the same page. So what is ASSISTments? ASSISTments is something that my husband and I, we are both teachers. We actually met in Baltimore teaching middle school math. He's the guy in the orange tie there. And he and I started ASSISTments, and we have built it along with multitude of graduate students at Worcester Polytechnic Institute here in Worcester, Massachusetts. And we also include a lot of teachers. So teachers are super important. We were teachers, so we really believe we built something that teachers can use. And so it was really important that teachers were involved. It is a forever free math formative assessment tool for teachers. We will never charge for this as a teacher tool. It enhances your curriculum. It is not a curriculum in its own right. And so you can assign online from many different pieces of content that we have in ASSISTments. So it's the teacher's choice what they assign. And it allows for every assignment, anything that you assign, to be a part of that formative assessment process. And it seamlessly integrates with Google Classroom and Canvas. And that's just important for ease of use. And, you know, one of the things that we're thinking about today as we're thinking about all this technology is how we're going to do this in this time of distance learning. And ease of use, of course, is super important for you and your students and those parents out there as well, I think. So ASSISTments is designed for formative assessment. We were teachers. We really saw a need for technology to come in, and our ideas fit perfectly into this cycle. But as we go along, I want you to think about the paradigm, the framework that I'm trying to cover here with ASSISTments and the formative assessment cycle, and use it to think about the other tools that you're using. So if you want to just go into the chat right now and just chat and post some of the other tools that you're using that you think of as formative assessment tools, just so that we get a sense of what some of those things are. And as you're doing that, let me just sort of say, you want to make sure that that human technology back and forth is always there. And so I'll be talking about that as we look at ASSISTments. Cindy, any interesting tools that you see?
Oh yeah, all kinds of them. Khan, Flipgrid, Padlet, Delta Math, iReady, Pear Deck, Desmos, Zern.
I think I've heard Kahoot. Yep.
Edulastic.
Yeah.
Yeah, Google Forms, just people using Google Forms, GoMath, IXL, Prodigy, Edpuzzle, Seesaw.
Those are, I feel good. I think I recognize 99% of those. That's great. So yeah, we fit in that land. And so where does the actual technology fit in this whole cycle? And that's what we're going to look at. Thanks, Cindy.
Yep.
So with ASSISTments, the first step in the process, of course, is selecting your learning targets. And that, as I mentioned before, is done by the humans. You guys are deciding where your learning targets are. And then the place where we really step in is in the eliciting evidence of learning. So how do you find out if learning is, did the learning happen? And so what I'm gonna do now is I'm gonna swing over to ASSISTments and show you what picking that basically a problem set or an assignment or an assessment, homework, do now, exit ticket, whatever you want to call it, picking that assignment so that you can elicit that evidence. So I'm going to swing over here. Oops, wrong side. Over here. Sorry. Here is ASSISTments, and I'm going to go to Explore Content. And we have lots of things that teachers can choose from. There's the open educational resources, some of these curriculum that you may be familiar with, illustrative math, Open Up, Engage New York, Utah Math. We also have some textbooks. We have these special skill builders, and we have some other just problem-solving problems that you can choose from. For today, I'm going to dig into illustrative math, and I'm going to go in as a 7th grade teacher. And then we have all the units that these are open educational resources. So their content can be put into our platform because our platform's free and these content are open source, are published under the open source. So I'm gonna go into practice problems and this second assignment here. And the teacher can pick which ones of these problems they want to use to elicit evidence of learning. And I'm gonna scroll down here and pick this one, this problem about these congruent polygons, and then assign it through Google Classroom, select my class, and then assign it, and it goes straight into my Google Classroom, and then I can see that in my stream, and my students can see that in their stream. So that's that assigning part where the teacher has to pick what they're going to what they're going to use as their assessment. So that's that part. Now what I'd like you guys to do is to dig in and take some time to understand this math problem, because we're going to look at results and look at this problem in depth. And so I need you guys to all sort of have solved this. It's not too complicated. If you're an elementary school teacher, I think you can, well, see how it goes. We'll be giving lots of feedback today. So if you don't, the math itself, the arithmetic is pretty simple. And I'll set this timer and give you a minute to do that. All right, we did it. We made it to our minute. Hopefully everyone's had a chance to solve this problem. I'm going to ask you a quick poll question. And there it is. Which part of this problem, part A, B, or C, do you think students are most likely to get wrong? And thanks for waiting. I got about 130 people responding. I'll get up to at least 170, maybe 150. We'll see, and we'll take a look at our data. And then maybe you can put into the chat why you thought your different response. And I'm going to share this result. So it looks like we're part C is our highest one, and part A is our second highest, and part B is our third. Cindy, anything in the chat that's sort of giving rise to why we think that these different parts?
No, one of the things, people just want to know if you can put the problem back up.
I was going to just do that. Hey.
So we're getting a lot of, it's counterintuitive.
Part
that,
C is counterintuitive.
Yeah.
Right.
They think everything doubles because everything doubles.
Yep. Doubles or halves.
Yep.
Yep. Yeah. And it's funny because the kids are looking for patterns, and that's good. And they tend to think that it's not the same. It should be halved as well. Yeah. Yeah. Cool. Here's another question, and then people can pop this in the chat. Is there any common wrong answer that they're expecting to see in this whole problem? And what are we seeing, Cindy?
41 is a big one.
So 41.
Yep, the angles will be half.
Yep.
Yep.
Awesome. So we now have a sense of this problem, and we're ready to go and look at what it looks like in ASSISTments. So Cindy's going to put this bit.ly into the chat, and you guys can go there. What this link does is it takes you to a public preview of this problem for you to look at. But for those of you who just want to follow along, and I'm going to get certain parts of it right and wrong so you can sort of see the type of feedback that ASSISTments gives. I'm going to go and do this as you're doing that. So those of you who like to be active and actually push the buttons, go ahead and do that through that bit.ly. And those of you who just want to follow along, or people can try to do both depending on how much screen space you have. So here's the math problem in ASSISTments. And it's got 6 parts to it. We break down the problem into every single answer that the students are asked to do. That problem that we just saw on the screen comes directly from Illustrative Math by Open Up Resources. And so it's just asking for those 3 parts. Kids would typically use a piece of paper and write down their answer, but in ASSISTments, they get to type it in. So I'm gonna do a couple types of answering, getting it right and wrong. I'm gonna get this first one right so you can just see when you put in the right answer, it gives you a check, tells you you're right, and then you go on to the next problem. It asks us to explain our reasoning. And I actually saw on a report, a student who had gotten it right said, I don't know, I guessed. So here's a student who got the answer right, but then this is what they gave to their teacher as an information in the explain. Kids can, of course, write anything in there. And this next one is the finding side C. And so I also saw on that same report, students typing in a 2 as their first answer, 2/5 was another try, and then getting it right on that 3rd try. And so when that happens, the student gets a green X. And that's sort of saying, you got it right, but you didn't get it right on the 1st try, but you got it right between this partial credit. You can see a partial credit bar off to the right. It kind of shows you this sort of, you're in the zone of getting it for a portion of the credit. Then this one's part D, and I'm going to show a student who struggles a little bit more and actually tries and exhausts that partial credit so that you can see what that looks like. So 2.5, and then maybe I tried 2, and then I'm going to try 5 and get it right. And so if you exhaust the partial credit, you can see that's a 0 over on the right, you get a red X. And so that's showing you didn't get it within that partial credit. This next one, this is that one everyone was talking about how students usually cut it in half. And so I'm going to do that. I'm going to say 26.5. And then I'm going to submit that and it's wrong. And let's say a student is like, whoa, I thought we had to do half and 2. I thought I had this. They can actually see the explanation. In this instance, it's a video. And they can play the video. And the teacher.
So we learned that in scale.
And I won't play the whole thing, but the video will give them an explanation. At the end, the video, if it's an explanation, will also give the answer. So a student can type in the answer and either attend to the video or not. You know, we all know the students are going to do what they want to do. And part of our job is to help motivate them to want to watch the video if they don't understand it. but that's the case here. And notice in the upper left-hand corner, I have a red X, but maybe you can see it, maybe you can't, but there's a yellow tone behind it. And that yellow means I saw the answer. I did not get that without seeing the answer. And that's super important for both the student and teacher to see. And then I'm going to go to the next problem. And I just got that feedback. So I might be able to get this one right this time. So I'll get this last one right. And that's the finish. In a normal link that a student has in ASSISTments, they would then go to a report. But since this is just a demo link, it goes back to ASSISTments. All right, so that is the student experience. So we saw that. Now, what I want to do is break up this experience with respect to our definition of formative assessment. So when the students are working, I would argue that that time when they're receiving feedback and they're looking at the partial credit and they're seeing the explanation, they're adapting. So we're allowing, by giving that feedback as they go and not having them have to wait till the end or wait till even longer the next day, we're allowing the students to make their adaptation and adapting and making their, looking at their learning needs right away. I would argue that that student who got to that second to the last problem and typed in 26.5 and then looked at the video, that because they know there's more questions coming up right then and there, they might attend to that video a little bit more carefully. And that is an adjustment that a student has to make. Like we can't get the students to do things unless they're motivated to do it. And that's where this adapting and adjusting becomes more important through formative assessment, because the student knows I'm going to get checked next. It's important for me to know. And so we hope that formative assessment will get the students to make more adjustments. Obviously, this whole activity is eliciting evidence. And it's evidence not only for the teacher, but also for the student. The student can see right away how well they did on this problem set that they were given to by their teachers. And they have to interpret that evidence. And they have to see what those checks and X's and whatever that's what ASSISTments hands out. Every tool has its thing. And they have to be able to interpret that. They have to be able to understand what these things mean. And I'll tell you, at the beginning, when students just start using ASSISTments, they tend to, when they interpret an X, they get really upset. Their interpretation of that is like, oh no, I did bad. I'm a bad math student. But then later on, they start to learn, with encouragement from their teachers, they start to read and interpret this information differently if they're thinking of it as a learning thing. So that's the goal. One thing we do, and we had a teacher, and Cindy's going to put this link into the chat. We can get the students, this is the teacher, the human's job again, is to get the students to think about these green checks and think about the red X's and what those might mean to them. And so this is a graphic organizer that a teacher has used to help the students interpret the evidence that's been found for them. All right, so next I'm gonna go off and show you the report that the teachers get. So teachers get a report, and that is right here. So let's just take a look at this for a minute. What do we see? So a teacher who's gonna come at this report is probably gonna say, oh wow, 48% correct, and they're gonna see that number. They're gonna also see that 70% of the students who got it wrong said 26.5. So this is real data, these are real students. And that's probably a super important thing to take note of. And we all the teacher and you and I, we all know what this problem's about. That's where they said half instead of the whole amount. Over here, we can see 77% of the students got this first one right. So that's an interesting number. The teacher can click on essay grading, and they can see all in one place the things that the students said in that explain section. So they can read down these and see, are students answering these questions the right way, the way I would like them? And they can give feedback for that too. So those are some things that the teacher can see in this report. They can also sort and be able to do that. So I'm going to go back to my slides, and I'm going to get rid of this. There we go. So these two are next to each other. All right, and let's take a look at this framework again. So we have this framework of formative assessment. So this is interpreting evidence. Obviously, looking at this report and reading this report is interpreting evidence for the teacher now. And the teacher can take a look, they can see their class as a whole. They see all the students' names on the left-hand side, they see the problems across the top, and they can work to interpret that evidence. Something else that's kind of interesting is this developing of a criteria for success. So it's what is considered successful at this point in time. So let's take a look back at this report. And this teacher could be thinking, wow, 48%, that's really low. But if we think about it in context, is this at the beginning of the learning trajectory, or is this at the end of the learning trajectory? I happen to know that this assignment was done at the beginning. So the beginning of the learning trajectory, I know that I have a pair of problems. I have where they asked for the angle that was equal to 53. I can't remember which number that was. And then they have the other angle that was equal to 82. Since this pair, I know about this pair, when I want to create a criteria for success here, the fact that I've got 98% right on the second question is looking pretty good to me. And if I sort this, I can see that the student who got it wrong, there's only one student who got it wrong, actually said 53 first. Well, that seems like a glitch. That seems like a student who wasn't reading the question correctly, and they got the feedback on that. I'm good with this. If it was at the end of the learning trajectory, I might be a little more concerned that they slipped into this misconception so quickly. And so it's really important, again, that the human is involved in interpreting that, that formative assessment move of deciding what criterion. The 77% might be a kind of low score. And so as a teacher, what I might do is I might sort this and just see which, then of course this is anonymized right now, these names are gone. But which ones of my students didn't get this right on the first try? These two said 1/2 first, and then they got it right on the second or third try. They're probably fine. I might want to pay close attention to these 4 students. And so this gives some teachers some understanding using that criterion. So that's a super important part of looking at this assignment report. So this brings us to the adapting and responding to learning needs. And I'm going to show you 3 different examples of how teachers respond to learning needs. This first one is the teachers can take this report and they can anonymize it, taking all the names away, and then it scrambles the list. So students at the top of the alphabet aren't at the top of the list. And then they can just show it to the class. And so Ms. Razak here is pointing out some places where students are low. She might respond to some common wrong answers. Now, this example is something that came out of this spring. So during distance learning, everyone went home and everyone's trying to teach from their computers. And this teacher, Andrew Burnett, he's used to going over the report. His students are used to the report, but he put his report review online on a video, and then he sent it to his students. His students were doing all of this work asynchronously. So they did the work on ASSISTments at their own time, and then in their own time, they saw this video from him. I'm just going to share this with you.
Hey there, everybody. So we're going to take a look at last night's learning opportunity, or yesterday's learning opportunity. So as you can see from the scores, you did quite well. 93, 95, 100, lots of 100s, 87, 88, 100, 99, and then 63. So there's just this one question that gave you difficulty, and it was based on is her account balance proportional to the number of weeks of deposits? So let's take a look at actually that problem. You might recall, actually I'll go back and we can click on the actual problem itself so we can look at the problem, and then what we'll do is we'll take a look at the work that that I just showed you briefly. But this was the one where at the end of the summer job, Caitlin had saved $120 from her summer job. And then she's going to, that's her initial deposit into the bank. And then as the school year starts, Caitlin is going to deposit another $5 a week. So if you look at the table on this, you'll notice that she started with $120 when she's at week 0. So if you were to graph this, this doesn't start at 0, 0. It might be a straight line going up $5 every single month. But what happens is it doesn't start at 0. So the fact that this is not 0, 0 right here, that means it cannot be proportional. So I hope that this was helpful for you, and good luck.
So I know some of you are from different grade levels, but this is a small little thing, very similar to what we were just talking about with the angle. It's a small thing to know that the angles stay the same, and it's pretty easy to know once you know it. But if it doesn't get caught, it'll just be a systemic problem in the kids' understanding of the math, and they'll just keep having these little pieces of misconception and misunderstandings that pile up on each other. And so formative assessment allows for us to know where we got it, make the adjustment, learn this little piece. That's exactly what Andrew was doing here, and then move on. So this is a really nice, a nice demonstration of that. Now, this next video I'm going to show you is a teacher, and sorry, it's going to bring us back to those days when we were in the classroom and all the students were sitting around. But I'm really excited to see actually from Mr. Driscoll here, what he does with this sort of review this fall, because I'm sure he will be doing distance learning, and find out how he does this sort of feedback to his students with the distancing. But this, you guys can start to think.
So we had a homework assignment where you had to do ACE 11C, which was found on page 18. One of the things I noticed when I looked at ASSISTments was that although the correct answer was 800,000 square centimeters, more than 1/3 of you answered 4,000 square centimeters as your first choice. And a lot of you needed hints to figure out why 800,000 square centimeters was the correct answer. So here's what I'd like you to do now. I'd like you to have a conversation with the people that you're sitting with and try to figure out first why 800,000 is the correct answer, and second, why did so many students come up with 4,000 square centimeters as their first answer?
Hello, my name is Chris Driscoll, and I teach 7th grade math at Falmouth Middle School. The clip that started this video is the launch to an activity where students are going to analyze a common mistake in a homework assignment that I discovered because I use ASSISTments. I noticed that more than 1/3 of students gave the same incorrect answer, and I wanted to see if the students could figure out why.
20 times 200 times 200 again. Yeah.
All right, I'm gonna have to stop, unfortunately, so we have enough time for questions and answers. But they go on to have a discussion about that. Notice he didn't go over everything. He dealt with his criteria for success, and he found this one place to hone in. Once again, probably at the beginning of the learning trajectory, he knew he could cover the other things later, but he really wanted to hone into this one systemic misconception. So that's it. We've gone through the first 2 things in our agenda, and we're on to research. I just wanted to start by saying that formative assessment research has been around for quite a while. Black and William came out with their black box review, where they reviewed a lot of different research. Let me just read the beginning of their abstract of this paper that came out in 1998. It was actually published online in 2006. If you can remember, there was a time when we didn't publish everything online. This article is a review of the literature on classroom formative assessment. Several studies show firm evidence that innovations designed to strengthen the frequency feedback that students receive about their learning yields substantial learning gains. So you do formative assessment, you're going to get learning gains. The trick, that's my conclusion, the trick is that it's hard to actually give all that feedback. It's hard to get that data unless maybe technology is helping you out. And in that research realm, what we were able to do is we got SRI, Stanford Research International, to do a study on assessments and see if in fact having this as your formative assessment tool would change student outcomes. And they were able to show that students who regularly use assessments scored approximately 75% higher than students whose teachers were not using the program. It was a randomized controlled trial. There were 44 schools and they were split into 2 groups, and half the groups used assessments and the other half didn't. An extra bonus result was that those students who had lower achievement at the beginning of the year actually grew more. And so that sort of was narrowing that achievement gap. And we were super excited to see that result as well. So formative assessment, there's a lot of research out there. If you can get all the pieces, and our training of the teachers in this study made sure that they were doing these pieces. If you get them all together, the human along with the technology, you can really improve student learning. So that's our last part of our agenda, and we are just a few minutes over, sorry, Charles, and ready to go on to do that discussion.
Fantastic. Thank you so much, Christina and Irina. That was great. So we've got a bunch of exciting questions to go through from our audience, so I'll kick us off straight away. Carol is asking, how could or should these practices about formative assessment be adapted for special education students?
So I'm not an expert in special education, but I would imagine that the importance of the human, and so your role of understanding your students is what becomes super important, right? I don't know if you noticed on the report, there was a blue line with a bunch of blue dots. The teacher excused the student from that report. So making choices about individual students because of their needs is part of the human being involved. And so you have to be careful about technology taking over because it might not be designed for those special needs students.
Let me add here just a quick comment. So as you saw, this is customizable tool, and you can scaffold the questions like parts, right, in the questions so that some of them need to be answered by all students to meet some basic mastery level, and then additional questions would be open to all students, but you will not really assess your special ed students on those additional questions. Or you will treat differently the access to videos and the access to help, maybe providing additional videos with hints that could be useful for everybody, but you will assess it differently for your special education students.
Yeah, I think that green field, the criteria for success is a place for adjustment.
Great, thanks so much. So Myra has a similar question, but with respect to English language learners. Are there any adaptations that could be made for English language learners?
So right now, like the tool, if you run it in Chrome, you can actually get a read aloud for the text. So that's one nice thing. We're currently full out trying to add any features we can. And there's one that we'd love to add, which is that read aloud of the problem, which I think would support the English language learners. There is no reason when someone's building their content, they could make like 2 different languages for the problem. Once again, I think it's that selection. If you have a group of English language learners, you might not want to select as many problems that are reading heavy. Or you provide the scaffold if you want to make sure that they're staying at grade level and doing the things that are appropriate for them.
Thanks so much. This is several people have asked when an ASSISTments standalone version might be ready.
Yeah. So we're working right now. We have a standalone version. We call it 1.0. We have our original platform that we developed solely at the university. About a year and a half ago, we spun off a nonprofit, and the nonprofit's been really working hard to shore up this sort of ASSISTments 2.0, we call it, and it is a smaller product. We're working we have funding, but we need time to have it reach out to all the different features that our 1.0 product has. And the 1.0 does stand alone. So if you actually go to our site, scroll to the very bottom, there's a link into the 1.0. It's a little clunkier to use. It wasn't designed to be, this new one has a lot more human computer interaction going on that's easier to use. And it's so you can use that if you need a standalone. We're currently working to integrate with Schoology. We get that question a lot. And we have an LTI, which is a learner, I don't know, they can't, LTI, I won't even define it for you, but it allows you to take the program into lots of different LMSs, sort of without a customized version. So that's something that's important for us too.
Great. Thanks. John has an important question about how do teachers ensure that the online assessments are private and secure?
Right. So we do have a privacy policy. You can go down and read that, but we keep the results under lock and key. They're actually at Worcester Polytechnic Institute, and so it's very important to us that those are secure. The passwords are completely protected, and the HTTP allows that protection as well.
Is there anything more generally that teachers should be looking out for when they are looking at other software for privacy concerns?
Oh, for privacy concerns, I think that you want to look at the privacy policies of the different organizations and the different platforms that you use.
Sean wants to know, do you have any advice for teachers who are moving from predominantly paper-based grading to more electronic and online formats?
My first piece of advice is to make sure that your students are still using some form of writing and paper. Like, your students need to be solving the math problems. I have yet to see, like, the problem we did, the reason I picked it was because it was probably doable without paper and pencil. But most of the problems, like, imagine just tweaking that a little bit with some different numbers. You need paper, I need paper and pencil to solve that. So first of all, make sure that your students use notebook paper. And I'm a kind of a big fan of not calling it scratch paper, because it's not about being scratch. It's about being the place where I organize my work, and that when we gather to look at the data and make our adjustments, I can track down my work. So in ASSISTments, I didn't show it, but that place where I wrote that little message, students can actually upload a picture. So they can upload their drawings, and so their work is in one place. So you can insist, and you have to train the students to actually take pictures of their work and upload it. If they're using a phone for their math, it's pretty good. If they're using they can do their webcam. I've seen this in ASSISTments, the little kids, like their face poking around. But that, you want to be able to collect that. And then the rest of it can kind of, your end of it can be done all online. So that would be my one piece of advice. How's that?
I can just add, like, when teachers start something new, it's always overwhelming. So don't try to do it all. You may review already available content and use that, so you don't have to create your own. Or you could use your paper and pencil test and just transfer them to ASSISTments because it has a content builder. But don't try to create something completely new on top of everything you're doing. Just take small steps.
Yeah.
Very, very sound advice. On a related question, Brittany wants to know is when she's presented with a new technology to use in a classroom, what's the #1 question that she should be asking that technology? What's the first thing she should do?
I mean, I think that it's number 5. Like, ask yourself about, I think formative assessment is just super important. And it's but it is not a one-stop deal. Like, there's no one way of doing it, but ask yourself, if I'm using this technology, is it going to allow myself and my students to know how we're doing and to make that adjustment that we need to really learn? And so, obviously ease of use, is it going to be frustrating? I think Irina, one step at a time. I worked with a teacher, she and I met 10 years ago, and she said she was always learning one new tool at a time. So one tool at a time. Maybe it'll take you a day to learn it. Maybe it'll take you 2 weeks to learn it, but don't try to do too many tools. And I think, but that's different from your question. Your question is what you should be asking yourself. I think, how is this helping me and my students make the next step to learning and knowing what we know?
And we are going to share a slide deck with the participants who want it. And I just want to refer back to one of the slides where I had a list of questions on use of technology. So you may look at those and think about like, okay, these are the questions I need to ask myself about using technology. So some of them may be more relevant or less, but that would be a good advice as well.
Yeah. It's important to understand too that there are more than one type of technology. You know, like a graphing calculator and something that will solve, like there's that technology that allows you to put your phone over the problem and it gives you the answer. So that's something, you know, and that might be a good tool. But it might be a good tool that comes along with showing your work. So if you're asking the students to show all their steps and be able to, you know, maybe talk about it later, you want to decide where is it helping and where is it getting in the way. But that's a different type of tool than what I just described. ASSISTments is really a communication tool, if nothing else. It's a place for me to put my answer, and me as a student, put my answer in and be communicated back whether I got it right, and to give me feedback. There's that communication between the computer and me as I'm working, but then there's the communication back up to the teacher about the results. So ASSISTments is not really doing any math, it's just communicating. And that's super different than a good graphing calculator.
Totally. So Tamara has a very timely question. Teachers are going back to the school and they won't necessarily be meeting their students in person. They will just be interacting with them online. Do you have any advice for dealing with that?
I don't have a diet. Good luck. I would say, but for advice with using ASSISTments on that, because that I can at least say I've been thinking about personally, is give them problem sets that are, we have a practice problem set online that you can find that's a good place to start, because it's not about them knowing or not knowing something. It's just about being able to put the answers in. They have to learn to interpret the data. So they need to learn to understand the way the data is being done. So you start there, let them know that that's the case. Then I would say doing something that's not, that's something where you know that they're probably going to get answers wrong, but that's not really a big leap. I think that question that we just did, the one about the angles and congruent angles, is a perfect one, because they're going to get it wrong. You know, we're kind of all know that, especially after the summer slide. But learning how to do it right, they're going to feel a lot of confidence. So the other one that I like for that one is, like, if you're working with 8th graders, give them some integer subtraction problems, or something that they'll get wrong. So they need assessment. So they'll see the point of this, but picking up that skill that they really learned in 6th and 7th grade is probably not so hard. So finding some good skills like that to get started with, so that they see that it's purposeful, and then really constantly reviewing the data so that they know that it's not a place for their grades, it's a score. We use the word score all the way across ASSISTments, so that it's not about grades, and trying to really instill that. It takes a little bit of time for them to get into that, but that would be the place I'd start with formative assessment.
I would also add to that I think you want to establish the very beginning idea that making mistakes is a process of learning. So they don't, when they go, especially when they're on their own working with a system like ASSISTments and getting like feedback, and they may feel frustrated when they don't get things right away, but they've probably been taught that they need to get mathematics everything correctly. So learning is making mistakes and working through mistakes and trying to understand those mistakes. If you establish that kind of culture, that is very important, especially online, because they will not have you to support them in it every moment, because you will be online and they will be on their own and they don't have their peers next to them. Right. So making mistakes is perfectly fine, and you need to celebrate making mistakes, because that helps us to learn.
Right. And that's setting that criterion for success. So you have to decide what the criteria is, and they have to understand that it's not getting them all right every time, you know, not for homework and any formative things.
Thank you both so much. And thank you to everyone who's joined. We're at time now. Just before we leave, where can we learn more about your work, Irina, and ASSISTments in your work, Christina? So,
ASSISTments you can find at ASSISTments.org. And just go to ASSISTments.org. I think Cindy will pop that in the chat. And you just have to remember that word. And there's lots of information there. We have a teacher's corner where you can see teachers' things. You can find this video that I showed you with Andrew. And so that's where it's chock full of information for teachers.
And for me, you can just go to TC website, and under Math Science Technology Department, you'll find a link where you see my research references as well as my email if you want to contact me. I do work a lot with technology. That is a major area of my research in the mathematics and science education. And I'm pretty good at answering emails. My husband thinks I'm an emailaholic.
Wonderful. Thank you again. And thank you to everyone for joining. It's wonderful to see so many people interested.
Thank you very much.
Thanks for having me, Charles and Irina.
Well, thanks for joining us. That was great.